256 megabytes, the beginning of a nightmare. It's 2003. Dial-up internet screeching in the background. You open Internet Explorer, wait 30 seconds, page loads. Life is good. Then you open Microsoft Word. Computer freezes. That hourglass cursor just spinning. 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 Your document gone. Your afternoon gone. That was 256 megabytes RAM. Every program fighting the others for memory like strangers fighting over the last subway seat. When things got crowded, someone got pushed out. Always you. Always before you saved your work. When memory ran out, Windows used your hard drive as fake RAM. Hard drives back then were slow spinning disks. Result? Your computer went completely catatonic while it figured out what to do next. Survivors of this era still hit Control plus S every 30 seconds today. Trauma runs deep. One Chrome tab in 2024 consumes more than 256 megabytes. Let that sink in. 512 megabytes, a little better. Still terrible. Slim flip phones. MySpace profiles. Manufacturers hand us 512 megabytes and say, enjoy. We did not enjoy. Switching apps on early Android phones was basically saying goodbye. Jump to maps from your messages. Come back. Entire conversation reloaded from scratch. Every single time. The app didn't pause. It died. On laptops, it was a constant mental game. Browser or music player. Document or anything else. You made sacrifices. You lived like a monk with a laptop. RAM speeds in this era were also embarrassingly slow. Low capacity and low speed. The tech equivalent of being broke and also losing your wallet. 1 gigabyte, the false dawn. Windows Vista arrives. Microsoft recommends 1 gigabyte. People feel hopeful. Vista then absolutely demolishes that 1 gigabyte and begs for more. Here's what nobody told you. Recommended doesn't mean comfortable. It means your computer technically turns on. Everything after that is your problem. 1 gigabyte handled basic documents, light browsing, older games if you ask nicely. Push anything beyond that. Lag hit you like a wall. That frozen taskbar. That moment you genuinely considered a career change. Today, 1 gigabyte lives in Raspberry Pi projects doing one specific job on repeat. That's where it belongs now. What's the worst device you've personally survived? Drop it in the comments. 2 gigabytes, the era of almost. Affordable laptops everywhere. Manufacturers shipping 2 gigabytes with straight faces and zero regret. The cruelty of 2 gigabytes wasn't that things didn't work. They almost worked. Chrome loaded, then crawled. Games started, then stuttered right when things got good. Permanent state of almost fine. Somehow worse than outright failure. Android with 2 gigabytes killed background apps like a sport. Switch away for 2 minutes, come back, reloading. Your phone couldn't remember what you were doing long enough for you to finish doing it. That seamless switching between apps you take for granted today, that exists because modern devices keep apps genuinely alive in memory. 2 gigabytes never managed that. Not even on a good day. 4 gigabytes, the sweet spot that got left behind. 4 gigabytes is the mainstream standard. Windows is lean. Browsers aren't monsters yet. Life is genuinely fine. Then everything grew up except the RAM. Windows 11 today idles at 1.5 to 2 gigabytes before you've opened anything. That leaves maybe 2 gigabytes of working memory for your entire life. 3 Chrome tabs, Spotify, 1 Google Doc, ceiling hit. Done. Then swapping starts. System shuffles data between RAM and SSD, constantly trying to compensate. SSDs are faster than old spinning disks, but nowhere close to actual RAM speed. That sticky, sluggish feeling when too many things are open, that's swapping. Happening right now underneath everything. Chromebooks survive 4 gigabytes better. Chrome OS was built lean from day one. Windows on 4 gigabytes in 2024, though, daily war of attrition you will eventually lose. Tired of your laptop making you feel like the bottleneck? Subscribe to Tech Unpacked. We tell you exactly what to fix. 8 gigabytes, finally some peace. Work from home becomes reality. Video calls, cloud apps, browser-heavy workflows for everyone. 8 gigabytes becomes the baseline that actually makes sense for how people use computers now. DDR4 RAM. what most devices ship with today, runs at 2,133 to 3,200 MHz. DDR2 from 15 years ago ran at 400 to 800 MHz. Same concept, completely different league. That speed jump alone changes how computing feels. With 8 GB, your OS takes its share, and you still have 5 to 6 GB of real headroom. Multiple tabs, music, Discord, a document. Open simultaneously without doing mental math first. That freedom is underrated until you've lived without it. Gaming on 8 GB covers most current titles, but newer releases are already pushing past it. Alan Wake 2, Starfield, 16 GB showing up on recommended specs now. 8 GB is today's comfort and tomorrow's limitation. Apple Silicon deserves a mention here. Unified memory means CPU and GPU share one intelligently managed pool. 8 GB on an M-series MacBook performs like 12 to 16 GB on traditional hardware. Not marketing, just smarter architecture. 16 GB, the part where you stop worrying. 16 GB is where the RAM conversation just stops. You open things. Leave them open. Work. That's it. DDR4 and DDR5 at this capacity keeps data moving between processor and memory fast enough that RAM stops being your weak link. Under 16 GB, there's a quiet, waiting game your processor plays that you can't see but absolutely feel. At 16 GB, that waiting disappears. Developer running local servers, containers, a full IDE, and 30-stack overflow tabs. Comfortable. Video editor cutting 1080p footage, no complaints. Streamer gaming and running OBS simultaneously, handled. 16 GB also buys you real time. 8 GB will feel dated in 2 years based on where software is heading. 16 GB gives you 4 to 5 comfortable years without thinking about this again. That's worth a lot when you're deciding whether the upgrade makes sense. Know someone about to spend money on a laptop? Send them this video first. Subscribe to Tech Unpacked. Expensive mistakes are completely avoidable. 32 GB, when your work outgrows everything. There's a specific moment creators and developers know well. The moment your computer stops keeping up with your ideas. Render crawling, timeline stuttering, project file taking forever to even open. That's when 32 GB enters the conversation. 4K editing in Premiere or DaVinci. Complex 3D scenes in Blender. Running Docker containers alongside a full dev environment. AI tools that need actual room to breathe. At 32 GB, modern high-speed RAM keeps demanding applications fully loaded and ready. After Effects holds more rendered frames in memory. Previews become instant. Virtual machines get properly allocated resources instead of scraping by on leftovers. Local AI models actually run instead of hitting walls every 5 minutes. Nobody buys 32 GB to flex. They buy it because their workflow demanded it and they got tired of waiting. 64 GB and beyond, a different world. This is where our story leaves everyday people behind entirely. VFX studios rendering film sequences. Scientists processing datasets that would take consumer hardware weeks. Financial systems handling millions of transactions every second without blinking. RAM at this level isn't a component anymore. It's infrastructure. Server RAM runs ECC technology, error-correcting code, that finds and fixes its own memory mistakes in real time. Because at this scale, one corrupted memory read doesn't just crash an app. It brings down entire systems and costs real money in real seconds. Consumer RAM doesn't do this. Server RAM cannot function without it. Multi-channel setups multiply total bandwidth. Registered RAM uses physical buffer chips for stability under extreme load. This isn't the same component with a bigger number. It's a completely different class of hardware solving completely different problems. For everyone else, the story ends simply. Buy what your life needs today, add 1 step of headroom for 2 years from now, and stop Googling why everything feels slow at midnight before a deadline. That's every RAM size explained. No fluff, no wasted time. Tech Unpacked. Subscribe and drop your current RAM in the comments. Flex it or confess it. We don't judge.